back to my channel. My name is PrachiSharma, and in today's session we are working on the important questions of nitric acid, and this is the second part. In the previous part we covered about 20 important PYQs of nitric acid, and this is in continuation to that. So this covers whatever left out questions we have that are in the last 10-year board examinations from this particular chapter. So without wasting any time, let's get started. Alright students, let's get started with today's session. A few things for you before we get into the questions is, the first is that if you have any queries or doubts, you can reach out to me in 3 ways. The first is leave a comment in the comment box. Second, you can write me an email at psclassesicsc@gmail.com. And the third, you can connect with me on Telegram. So whatever works for you, you can definitely reach out to me. The second thing is that the notes for every video are available in the description box. If not in the description box, you can also find them on the Telegram channel, because once the video is posted, notes are sent on the Telegram channel as well. So whatever works for you, you can opt for that method. Now, without wasting any time, let's get started with today's session. Alright, let's start with the first question. The first question says, give reasons for the following. During the manufacture of nitric acid by Ostwald's process, excess of oxygen is taken. So the reason for that is that oxygen is required at every step of the process. Now, Ostwald process is a long process and it's an industrial process. So at every step, you need a lot of amount of oxygen. Therefore, in the entire industrial process, that is Ostwald process, excess oxygen is required. That is the answer for the first one. B part. Before the gases are allowed to enter the oxidation chamber, the gases are sufficiently cooled. So there are two main reasons for that. The first reason is that so that your nitrogen dioxide doesn't get decomposed at higher temperature, because you have nitrogen dioxide, of course. Now, if you have a higher temperature, there is a tendency that nitrogen dioxide may get decomposed. The second reason is that nitric oxide. So, in the initial steps, you have oxidation of nitric oxide. So, to make sure that nitric oxide is properly oxidized and completely oxidized, you need to maintain the temperature lower. So, that is the answer for B. C. The gases entering the catalytic chamber must be pure. So the main reason for this is that if these gases are not pure, they will end up poisoning the catalyst in the catalytic chamber. And if that happens, the entire speed of the process or the entire speed of the reaction will be dropped, and you may not get sufficient amount of output in the required period of time. So that is the answer for C. Now D. Commercial nitric acid is pale yellow in color. So what happens is that when we leave out nitric acid in open air and you are performing an experiment when it is just sitting in the reagent bottle for a longer period of time. So what happens in that time duration is that gases from the atmosphere starts you can say getting absorbed into nitric acid and start reacting with it. But the main reason why it is pale yellow in color is because of the presence of nitrogen dioxide in it. Let's move to the next question. The following questions are related with the lab preparation of nitric acid. A. Name the two compounds used for the preparation of nitric acid. So what are the two compounds? Either you can use potassium nitrate or sodium nitrate, and along with that you can use concentrated sulfuric acid for the preparation. The next is, write balanced chemical equation for the lab preparation of nitric acid from the above named compounds. So you can pick up anything, whatever. If you have written potassium nitrate in the first answer, then use that equation, otherwise use the second one. So I'm just gonna write the potassium one right now. So the potassium one, let me change the color. So the potassium one would be KNO3 plus concentrated H2SO4 at temperature below 200 degrees Celsius. You will end up getting KHSO4 plus HNO3, and that's it. Next question is, name the gas in each of the following. the gas produced when copper reacts with concentrated nitric acid. So the answer for this is, now in this case you have to remember that copper is reacting with concentrated nitric acid. So when it reacts with concentrated one, you get nitrogen dioxide. So nitrogen dioxide. Now by now, if you have also done the first part of this video, that is the important questions part 1, in that case, in that video also we have done a question in which copper is reacting with nitric acid. So by now I hope you have realized that reaction of nitric acid with copper is extremely important. This has been repeated multiple times over the last 10 years. So make sure that you understand very well that how copper is reacting with concentrated nitric acid and how it is reacting with dilute nitric acid. Let's move ahead to the next question. Question 4th. Give reasons for the following. Iron is rendered passive with fuming nitric acid. Now this is because a thin oxide layer comes on the top of iron, which creates a barrier between iron and nitric acid, and hence your reaction stops. So therefore it is rendered passive. That means no more reaction occurs when you have nitric acid along with iron. Let's move to the next question. What do you observe when copper is added to concentrated nitric acid? Okay, it is just the observation. So when you have the observation, then pinkish red metal, the metal that you have, it dissolves to give a blue-green solution with the liberation of reddish brown colored gas, and which has a pungent suffocating smell. So this will be your observation. So pinkish metal, which will make the solution bluish green, and it will end up giving you a suffocating, reddish brown suffocating rotten egg smelling gas. Not rotten egg, suffocating pungent smell. So that is what the gas would be. Now next question is, write equations for the reactions dilute nitric acid and copper. So in this case you have dilute nitric acid. Alright. So let me write the equation. So this will be HNO3 plus copper, and this will give you CuNO3 whole twice plus water plus NO. You get nitric oxide. Okay. So concentrated nitric acid, you get nitrogen dioxide. Dilute nitric acid, you get nitric oxide. Let's move on to the next question. Write balanced equations for the following reactions. The first one is sulfur and hot concentrated nitric acid. The next is sodium nitrate and concentrated sulfuric acid. Okay, let's write the first one. So sulfur plus HNO3 will give you H2SO4 plus NO2 plus H2O. And sodium nitrate and concentrated sulfuric acid will give you NaNO3 plus H2SO4 plus H2SO4 will give you NaHSO4 plus HNO3, and the condition you have to mention, it is below 200 degrees Celsius. Let's quickly move ahead to the next question. Question 8. Write balanced equations for the following reactions. The first is oxidation of carbon with concentrated nitric acid. So when carbon reacts with nitric acid, let's write that. So carbon plus nitric acid will give you carbon dioxide plus NO2 plus water. And the next is action of hot and concentrated nitric acid on copper. So copper plus concentrated nitric acid. So HNO3, and in this case we know that you get nitrogen dioxide. So that is NO2 plus water will come out, and you will get copper nitrate, CuNO3 whole twice. Let's move to the next question. Name the products formed when a mixture of carbon and concentrated nitric acid is heated. So you already did that up here. So what are the products? That would be carbon dioxide, water and nitrogen dioxide. That's it. Now next is dilute nitric acid and added to copper. Again, I hope you realize that how many times the reaction with copper and nitric acid has been repeated. The reason I have mentioned all the type of questions is so that you get an idea that how they have asked questions with copper over different years. So, and you understand the different methods of asking the same question. Now in this case they are asking only the products. Make sure that you don't write only the formula but the whole word of the compound. Now in this case they are asking dilute nitric acid added to copper. So in this case what will you get? You'll get copper nitrate, you will get water, and you'll get nitrogen dioxide. You'll have 3 products. Let's move ahead to the next one. Oh sorry, you have dilute, right? In dilute you get nitric oxide, not nitrogen dioxide, nitric oxide. Let's move to the next question again. Complete and balance the following chemical equations: Cu plus HNO3 dash dash and dash. Now when this question came, there was a lot of fuss about it because they did not mention whether this HNO3 is dilute or concentrated. So depending on what you are taking it, you got marks for it. But provided you have mentioned in the bracket whether you are taking dilute or whether you are taking concentrated. So no matter what you took, if you have mentioned it and given the right product, you got the marks in that year. So that happened. For now, let's just take it concentrated. So if you're taking concentrated, you have NO2. Oh, I'm sorry. This was not that question that I was talking about, because in the products, they have mentioned NO2. Since they have mentioned NO2, that means this is a concentrated HNO3. So this is not the question that I had in mind. This is a different question. So since it is NO2, that means nitric acid is concentrated. So what are the other products other than NO2? You'll have water and you'll have copper nitrate. That's it. Let's move to the next question. Give balanced chemical equations to produce the following salt. Lead sulfate from lead carbonate. Okay, this is a very popular question and very important question. So you're supposed to form lead sulfate. So that means lead sulfate is your final product. So you can write lead sulfate, PbSO4. You're trying to reach PbSO4 from lead carbonate. From lead carbonate, we'll write lead carbonate here, PbCO3. Alright. Now from carbonate, you need to reach sulfate. You cannot go directly. There is no way that you can go from carbonate to sulfate directly. So what you'll do is, for getting up sulfate, what you can do is, you can add up nitric acid to a carbonate. So when you get nitric acid in a carbonate, you end up getting lead nitrate. Once you have lead nitrate, you can react it with concentrated sulfuric acid and add up SO4 in your lead. Okay, so lead carbonate reacted with nitric acid, you get lead nitrate. React lead nitrate with sulfuric acid, you end up getting lead sulfate. Okay, let's look at it in the form of equations. So you have carbonate, you reacted with nitric acid, so HNO3, you end up getting lead nitrate plus water plus carbon dioxide. Now you use this lead nitrate, so Pb NO3 whole twice, you reacted with H2SO4 and you end up getting PbSO4 plus HNO3. Okay, so I hope this makes sense to you. Let's move to the next one. Identify the gas evolved in the following reaction when sulfur is treated with concentrated nitric acid. So we already did this one. Okay, they are just they're not asking the equation, they're just asking the identify the gas. So the gas will be nitrogen dioxide, because if you remember, we did sulfur plus HNO3 and that gave us H2SO4 plus NO2 plus water. So that means the gas coming out is NO2. Now a lot of students ask me that when you get observation questions, are we supposed to mention the equation? So the answer for that is no. You're not supposed to or not required to mention the equations. You will not lose marks for not mentioning the equation. So instead, if you're not confident about the equation, instead of taking a guess with the equation, I would say completely skip it and focus only on the explanation of the answer and not try to gain up extra marks, because you will not get any. But if you write a wrong equation, you have a high chance of losing a mark. So let's move to the next one. Fill in the blanks from the choice given within the brackets. Dash, a cold dilute nitric acid reacts with copper to form dash. Now dilute nitric acid will react to form nitric oxide. So the answer is nitric oxide. Now next is fill in the blanks using the appropriate words given in the brackets. Cold dilute nitric acid reacts with, so again see, this was repeated again. Copper and nitric acid comes together very often. So make sure that no matter what happens, you are very thorough with this equation. So cold dilute nitric acid reacts with water, reacts with copper to give nitric oxide. So this answer is gone. Hot concentrated nitric acid reacts with sulfur to form nitrogen dioxide. We just did that also. So that is the answer for this. Now let's move to the next one. Fill in the blanks using the appropriate words given. Cold dilute nitric acid reacts with copper to give. Okay, so in this one, you can also mention the name of the acid, because sulfuric acid will be coming out in this one, because you get sulfuric acid also, and for the first one you get nitric acid anyways. So what you can do is, for the second one you can mention hot concentrated nitric acid reacts with sulfur to form. You can give anything, either you can give nitrogen dioxide because that gas is also coming out, or you can also mention H2SO4, that is sulfuric acid. So any of these answer is acceptable. Let's move to the next one. Fill in the blanks. Nitric acid is a dash and dash acid. So based upon your information from acids, bases and salts chapter, you can write anything that you like. So for now I can go with, it is a strong monobasic acid. So strong monobasic acid. The salts of nitric acid are called nitrates. Rainwater contains the traces of nitric acid. Sulfur on reaction with concentrated nitric acid produces dash acid. So that will be sulfuric acid. Nitric acid in laboratory is prepared by the reaction of dash and dash acid. Okay, so dash can be anything. You can say potassium nitrate or sodium nitrate and H2SO4 acid. So sulfuric acid. Don't write formula like me, write entire thing, sulfuric acid. Let's move to question number 16. Nitric acid, liberation of hydrogen on reaction with metal. Pure nitric acid, brown ring test, mixture of niter and concentrated sulfuric acid. And on this side you have NO3 ion and all right. So let's start with the first one. So you have nitric acid. So that goes, another name for nitric acid is aqua fortis. So that should go with C. The second is liberation of hydrogen on reaction with metal. So that is what nitric acid does. So this answer should be the oxidizing agent. So when it has to oxidize, instead of giving, so you have hydrogen coming out. So liberation of hydrogen on reaction with metals is an oxidizing property of nitric acid. Now when we talk about pure nitric acid, it is colorless, so it should be E. Then you have brown ring test. So brown ring test, what do you basically test in that? You test the presence of nitrate ion. So that means in this case the answer will be A. Now the last is mixture of niter and concentrated sulfuric acid. This is the lab preparation for nitric acid. So the answer is B. Alright students, so this is it for today's session. We have covered up nitric acid completely. You have the mind mapping video present on the channel. Then you have a test paper on nitric acid. Then you have 2 PYQ videos of nitric acid, and these 4 videos combined together completes nitric acid end to end. You don't have to do anything else, and this will help you prepare entirely for nitric acid. So if you are focusing on revising quick nitric acid, you can work on the mind mapping video. If you've already revised and just want to practice questions, you can do that as well. Make sure that you let me know in the comment box below how you felt about nitric acid entirely, and if there is still any lag in nitric acid according to you. Second important thing is, make sure that you share this video with your friends so that it helps them prepare nitric acid as well, and you all are performing well, and of course this will help me move forward. Thank you so much students. We'll catch up in the next session.